Hi everyone, it's Jon Fischer for COM220L TI89 training. This is our second week of TI89 training, and we're on lesson 3. And this week I'm gonna show you something really cool. One of my favorite features of the TI89 is the equation solver. I love it. I think you will love it too because it makes your life easier. It's my goal here, to make your life easier. So temporarily I'm gonna make your life harder by asking you to follow along with me and do some problems, but in the long run, one of the coolest things about this calculator, and a way it's better than most of the other TI calculators, the graphing calculators, is that it has the ability to solve not just single equations, but double, triple, any number of equations, and it can do them with as many variables as you want. So we call that solving symbolically, when you have symbols in there, not just numbers. And so it's really powerful, and let's just get right to it. Mainly we're going to talk about the solve function, and as you can see, it kind of looks like an Excel function. It's got the command solve right here, and then it takes two arguments, an equation and then a comma, and then you got to tell it what variable you want to solve for. So you put in an equation complete with equals, and it'll solve for one variable. And what we'll see in the next screencast is you can actually solve systems of equations. So 2 equations, 2 unknowns, 3 equations, 3 unknowns. So if you have 3 equations, you could potentially solve for 3 variables. But if you have 1 equation, you can only really solve for 1 variable. And that's how it works. So let me fire up my TI89, and there we go. First thing you should do is clear your variables. So if you press X, you can see that my X is clear. There's no number stored there. And just to remind you, several ways to do this. If you go to F6, which is right here, it's yellow, so you actually have to push second, F1, and you could clear your A to Z variables that way by pushing enter and accepting the warning. You could also go to your variables here, so second minus, no, not minus, second minus, and this will tell you all your variables. I don't really have any variables going on here, but if I did, they would be right here. So go back to my home screen, and here's our first examples. So the one we're starting with is so simple that you don't need a solver. Everyone could probably just recognize that 2 times any number when it equals 4. Well, the only number that works is 2. X must be 2. But we know the answer, and that's why I wanted to start there, because that's the best way to see how this is working. So the solve command is in your algebra tools. When you push F2, you get your algebra menu, and you can see there's actually a bunch of different functions that you can access. So you can not just solve, but you could factor an equation. Remember factoring? And the opposite of factoring is expanding. You could find the zeros where an equation equals 0. All this stuff. We're going to stick with solve for now. So solve, and you just, again, put in the equation, comma, the variable. So it's pretty simple. The equation is 2x equals, so the equals is nice and handy, it's a regular key, 4, and then you would want to put in your comma, and then the variable you want to solve for, in this case x, close your parentheses and push enter. That tells us x equals 2. Beautiful. I'm sure you like it already. Let's go to the next one. So I'm going to do 2x equals 4y, and remember how you can just recall your function. If I had this cleared out, you just push second, enter, and that'll recall your last entry, and then if you do it again, it'll flip through backwards through all your entries since your last clear action. And I just want to make this say 4y. So what I'm showing you here is that you don't even have to get a number here. You can have this y in here, and it'll solve it in terms of y. So when you do this, it's just telling us that, okay, if 2x equals 4y, then x equals 2 times whatever y is. And that makes perfect sense. If y is 1, then you can pretty clearly see that x equals 2 times 1, x equals 2. So you can do this. I could even do this. This doesn't have to be a y. This can be an a. Remember how to get a. I need to access my alpha. Didn't quite work. Alpha. And it'll tell you x equals 2 times whatever a is. Check out this one. I could have a variable called Fischer. So 2x equals Fischer. So I'm going to actually use the alpha lock. I can lock my letters in, so second alpha gives me an alpha lock, and I can just go ahead and type in F. Oh, that's not what I wanted to do. Alpha lock Fischer, solve for x, and x equals 1/2 of whatever value is stored in Fischer. So pretty cool. If I recall this calculation here, 2x equals 4y. If I want to, I can solve for y. Remember, you can solve for whatever variable you want. That's just your second argument. So instead of x here, I am going to say solve for y. So I put a y here, and it's going to tell me that y equals 0.5 times whatever x is, and that makes perfect sense. That's the solution here. If x equals 2, then pretty clearly y is going to equal 1. And we've already seen that's true. So you can type in whatever equation you want, and you can solve for any variable in that equation. So it's very simple. Let's continue. 2x squared equals log of 10. So I'm going to clear this out and go to solve. So the equation is 2x squared. Remember, that's how you get the squared, the caret, equals log base 10 of 10. So to get the log, remember, the log doesn't appear on any of these keys here, so you go to the catalog, and that is a list, an A to Z list of every single function on your calculator. If I click on L here, it'll take me right to the L's, so I can skip and go right to log, and that's your log base 10. Log base 10 of 10, which is, I think, just 1. But that's okay, we don't have to worry about that, and I'm going to solve for x, so comma x, close out my parentheses, and notice I get 2 answers here. What does that mean? That means that there's 2 possible values of x, either positive 0.707 or negative 0.707. If I plugged in x into this equation, so let me do that. If I plug in 0.707 squared times 2, that'll give me log base 10 of 10, which is 1. Or if I do the same thing with negative, so here's the same calculation but with negative 0.707, also give me the same thing. You can see why, because it doesn't matter if you square a positive or a negative, still gives you the same answer. So the solver is also really cool because when you have multiple solutions, it'll give you both of them, or all 3 of them, or however many there are. So that's pretty cool. Let's look at some other examples. Here's some other ones. See if you can follow along with me. So solve 0 equals 8x plus 32, and I'm going to solve that with respect to x. Notice you have 3 regular variables on your front panel here, but you could use whatever variable you want. If you wanted to use here's the answer, it's minus 4. If I wanted to do that again, but I wanted to use the variable q, I could just type in the q, and as long as I'm solving for q, it should do that the same way. So that's nice, especially when you have big, long equations with multiple variables. Nice to keep track of them. Let's do this quadratic down here. It's a quadratic because of this square. We call those quadratics. So solve x squared plus x minus 2 equals 0. Take that with respect to x. And again, I get two possible answers, either x equals 1 or x equals negative 2. Both are solutions to that problem. By the way, if I go to, and this is just extra credit here, if I go to algebra menu and I go to factor, remember quadratics can usually be factored. The whole quadratic equation is a form of that. If I factor x squared, I'm doing this the long way, I'm retyping it, plus x minus 2, that'll factor it, and you can see where these solutions come from. Either of these, x equals 1 or x equals minus 2, when I plug it in here, are going to make this whole thing 0, so that's kind of handy. Okay, moving on. So I didn't give myself a lot of room here. Let me make this a little smaller. So you're seeing behind the scenes here. This is really privileged here. So there we go. Whoops. Okay, a few other things. Here's what I wanted to show you. So let's do this one real quick. 4t, and I don't have to use t's. I can use x's. There's no reason not to. It's more convenient because I have x's. I have an x button, basically. So this is 4 times x plus 5, close the parentheses, equals 7 minus 3x. And solve that for x, please. And I get one solution, x equals minus 1.857. That's correct. Let me show you what's going to happen with trig. So sine of theta equals 0. Now, the sine of theta equals 0, I'm going to, first of all, remember when we're dealing with trig, it depends, our answer is going to depend on what mode we're in. And there's two ways to display angles, degrees and radians. Right now I'm in degrees, and you can see that right here. So basically, when I say, when I put in this equation, solve, and I say sine of theta, and I'm just going to use an x here, no reason why not to, equals 0, and I solve that for x, you get a funny answer. First of all, what you have to recognize is my answer is definitely in degrees, and that is because I'm in degree mode. If I was to repeat this calculation and I change my mode, we covered that last week, I change the mode to radians, then I get a totally different answer. That's in radians. See the 3.14, the pi. The reason I'm getting that instead of the pi is because I think I am in approximate mode. So if you go to page 2 and you change that to exact, and I repeat my calculation, so I second enter it, that'll give me a slightly nicer version. So instead of 3.14, and remember pi goes on forever, it'll give me the exact pi. But what is this crazy stuff going on here, the at n2? Well, the reason it's doing that is, and I'm going to go back to degree mode, the reason it's doing that is because there are actually an infinite number of solutions to that. Go back to degrees. There's an infinite number of angles that when I take the sine equals 0, because remember, sine repeats. If I were to graph that, and we haven't covered graphing yet, but let me just bear with me here. I'm going to graph sine of x, and I'll do that for maybe 3,000 degrees. And we'll actually learn this next time. But what you can see is, where does sine of x equals 0? Well, here, 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 and you can see my point. It's going to keep on going. Sine of x equals 0 forever at a regular interval. And what this is telling us on our home screen is the at n3 just basically means at n is any integer, so any whole number. So basically, if you take any whole number times 3 and then you multiply that by pi, you're going to get your solution. So in other words, here's one solution: 1 times 3 times pi. And also another solution would be, the next solution actually would be 2 times 3 times pi. And the next solution would be 3 times 3 times pi. So basically what this is saying is just at n means integer, every integer. So starting with 1 and going to 2 all the way to infinity. So that's how you get your answers. So don't be intimidated by that. If we say, I'm going to make up a new example here. If we solve this, where I want to solve, where does cosine of x, where does that equal 1/2? And I'm going to solve that with respect to x, so comma x. The answer is in degrees. It's, check this out, it's 60 times 6 times the at n 4 plus 1. So all that means is, here's our answer. Here's my first answer. 60 times 6 times 1, because that's the first integer, times 4 plus 1. So that would be my first solution. And then my second solution would just be where this equals 2. And so on and so forth. 3. So that's how that's going to work. If I go up here, you can see that there's also an alternative solution. If you move backwards and you subtract 1, that's also going to work too. Okay, so moving on, take a look at this one. Something weird is going to happen here. X squared plus x plus 2. If I plug that in, so let me clear this all out. So solve x squared plus x plus 2 equals 0, comma x, just like all the other ones before it. And what we get is false. What does that mean? That means that x squared plus x plus 2 never equals 0. And instead of saying that, it just says false. So in other words, there's no number, literally no real number, that is going to give you an answer here. Now, that doesn't mean there's no imaginary number. If you guys remember back to your study of imaginary numbers, imaginary numbers are going to come into play when you do your electrical engineering, and it's kind of interesting. Never thought you'd use those, but they do come into play with electrical engineering, and so we call those complex solutions. So actually, you can solve this for the imaginary solutions, and so this has no real solutions, just to get that out of the way, but it does have imaginary, in other words, complex solutions. So if you want the complex solutions, you don't do solve, you do csolve. And if you go to your algebra menu here, you see that there's csolve, and the way I accessed that was in the complex menu. So csolve, and let me do that instead of solve. I could have also just added a C in front of the solve. And when I do that, Remember the little I? That's an imaginary number. Little I is the square root of -1, which is a number that couldn't exist. At least not in the real number system. But in the complex number system, it does exist. I know that's kind of strange, but you do use this in electrical engineering. So here are the complex solutions. So there's two possible solutions here, and you can scroll up to see them. And then there they are. They both involve I, and that's what makes them imaginary, because I is that square root of -1. Those are complex solutions. So if you ever have to solve for complex solutions, and you might have to do that with Mr. Mancia in electronics or circuits, then you use csolve. And this is what we're going to next. This is a system of simultaneous equations, and that'll be the next screencast. So I'll see you in 30 seconds. Bye.